Okay, in this video we're going to take a wee look at completing the square revision from National 5. Okay, so looking at example 2, remember completing the square is when we want to write a quadratic in the form where we have the bracket all squared and it's plus or minus a number at the side. And it's a very simple process. So if I've got y is equal to x squared plus 6x plus 10, then first thing I want to do is half the middle term, drop the x, take the square up, put it into a bracket. So that's going to be y is equal to open bracket, x plus 3, because I'm halving the 6, and I'm dropping that second x. The square comes up outside the bracket, so I've got x plus 3 all squared plus 10. But if I was to re-expand this and simplify, it would not give me the original quadratic. I have to compensate by taking away the square of the number inside the bracket. So I have to take away 3 squared. So that will give me y is equal to open bracket, x plus 3 all squared, and that will be plus 10 take away 9. So y is equal to x plus 3 all squared plus 1. Okay? So that's part 1 of this example done. It's written in that form of x plus q all squared plus r, where q is 3 and r is 1. The next part is new to us, where it's asking us to state the minimum value of y and the corresponding value of x. For this, we need to look at what turning this form into completed square form does for us, because it allows us to get the turning point, which is minus 3, 1. So if we think about this parabola, this is actually a parabola that's got a turning point at minus 3, 1, and it comes down to here and then goes on. So the minimum value is how low this parabola gets. This parabola never gets any lower than the y value of 1. Okay, it comes down as low as 1 whenever x is minus 3, but then after that the parabola turns and heads straight back up to positive infinity. So the minimum value is equal to 1. And when does that happen? That's when x is equal to negative 3. Okay. Let's take a look at the second one. So same idea. I'm going to drop the x, half the middle term, take the square up, keep the 1 inside the bracket. So that'll be y is equal to open bracket, x minus, now this time it'll be 3 over 2, because I'm halving 3, and I'm just going to get 1.5, but I'll keep it as a fraction, all squared, plus 1. Then I'm going to take away what's inside the bracket, so it's going to be minus 3 halves, all squared. Okay, I'm always subtracting the square of the number inside the bracket. So let's go ahead and start to simplify this. So I get y is equal to, open bracket, x minus 3 halves, all squared, plus 1, minus, now remember if I square a fraction, I just square the top and I square the bottom. So that's taking away 9 quarters. So y is equal to, open bracket, x minus 3 halves, all squared. Now 1 is the same as 4 quarters. So it's 4 quarters, take away 9 quarters, which is minus 5 quarters. Okay. Again, that's part 1 done. Part 2, hence state the minimum value. So let's get the turning point. The turning point is the coordinate 3 halves, comma, negative 5 quarters. It's always the opposite of the number inside the bracket, and then we keep the number outside the bracket the exact same. Okay, So I can say that the minimum value is equal to -5/4, because that's the y value, that's how low this parabola gets to. When does that happen? It happens when x is equal to 3/2. You could give these as a decimal if you wanted. I've just chosen to leave it as a fraction, as that is the most accurate number. Okay.